Hello there, this is Crash 12 here, and today I'm going to be drawing some electrical circuits in series and parallel to help anyone who is having trouble understanding how circuits work or how to draw them. So what we're going to do is we're going to show a few examples of series and parallel circuits. So I'm going to start off drawing battery. That is your average battery, which is usually about 1.5 volts. And connected to this battery, we have wires. And what we're going to do for this circuit is I'm going to draw one switch and one light bulb. So your common household light bulb. So the wires connect to the switch. And the switch is open right now because the electrons will not flow. And then connects to the top of the light bulb. Now, once you turn your switch on, the electrons will flow from the negative end. The negative end is the smaller line, and the positive is the larger line. So I don't know if you can see that. Yeah, so the smaller line is negative, and the bigger is positive. So the electrons flow through the circuit to make the light bulb glow. So the electrons will then go past this light bulb and repeat this process. Now this is a simple circuit diagram, and it's in series. Now, series means that there's one path for the electrons to go. So because the wires are connected as one whole circuit without any additional wires, it's series. So once you turn our switch on, the electrons will flow through the circuit to the light bulb to make it glow and repeat back. If it was in parallel, you could have many different circuits and many different paths. So you can have multiple light bulbs. So if one light bulb was to go out, the other light bulbs will still work. So I'm going to show a more complicated circuit now. It's still in series, but instead of having one light bulb, we're going to include three here. So we have 1.4 volts there, and switch, it's open, and then so there we have a circuit in series with three light bulbs. So what happens is once we turn our switch on, the electrons flow from the negative end like before. But because we have three different light bulbs here, each light bulb is getting only 0.5 of the volts because they have to share it because there's only one path for these electrons to go. So they're not going to be as bright or luminant because they're only getting 0.5 volts throughout each light bulb. And then the electrons go back and repeat the process as a whole series circuit. So that's a little more complicated, but it's still a series, so make sure you understand this. If you need any help, you can just comment on the bottom of the page. So now we're going to move on to parallel, and in this circuit we still have a 1.5 volts. So my example is going to be some Christmas lights. Now, because it's the holiday season, when you're hanging up your Christmas lights, your circuit is in parallel, because in your light bulbs, if one of your Christmas lights was to go out, the others will still work because there's many paths for these electrons to go. But if they were in series and one of your bulbs went out, they all would go out, and that would not be very good. So I'm going to show you an example of a diagram in parallel. So we have our battery, 1.5 volts, and we have a switch which is open. And then we have light bulb, light bulb, light bulb. Now that is our parallel circuit. So once we turn our switch on, the electrons flow, but instead of flowing throughout, they have different paths to follow. So each light bulb will get 1.5 volts instead of sharing it because these electrons can have individual paths, making these light bulbs much brighter than before. So that's the difference in parallel and series, is the fact that there's many paths and there's only one path. So that's about it. If you have any questions, like I said before, just comment on the bottom of the page and subscribe to my videos. That's also good. And you can catch up with anything I'm putting down. So that's about all I have to say. So thanks for watching, and bye for now.